is evolution premised on scientific evidence? Okay, so we will be conversing about this. Just give me a moment before I set up the stream here. Okay, the stream has come up right now, which is good. So just bear with me while I do this here. And Evo is with us. So just bear with me while I set up these things pretty accurately here. And just doing the right things on my end. So YouTube Studio. I'm sorry for this disturbance. I always mess it up. I'm not pretty good at doing these things for some reason, but we will be starting the debate shortly. So I'll just
Nice.
So, Ivo, you can go live right now. So, hello, everybody. Welcome to Prophet Daniel Has Spoken Research Channel. Today, we have a debate with Ivo and Prophet Daniel Has Spoken. The topic is as evolution premised on scientific evidence. So, the format goes like this. Ivo will provide us with an opening statement for 5 minutes, and following is my statement for another 5 minutes. And then we will be conversing the topic like one-on-one in a friendly manner. So belt up, guys. And Ivo, before you want to start the statement of yours? Do you want to introduce yourself, please?
Sure. My name is Evo Colossus. That's what I go by on YouTube. You can find me on @EvoColossus, and I'll also be restreaming the debate as well. And I'm ready when you are.
So yeah, Evo, we can really go and present the argument for is evolution premised on scientific evidence.
All right. So yeah, we agreed on 5-minute opening statements. So I will start a timer now. All right. The topic of the debate is whether evolution, by which I mean common descent by natural selection with modification, is premised on scientific evidence. Therefore, I think it makes sense to start by explaining what scientific evidence is. In science, we start with observations of the world around us, but our observations are subject to biases and errors. So, in order to make sense of them, we need a way to interpret them, and we need a standard of evidence to justify our interpretations. Science is a methodology which assumes that the natural world is knowable by developing theories from which to interpret the data. And scientific theories are justified on the basis of their ability to produce novel, testable, and falsifiable predictions. Thus, today, I will be arguing that the theory of evolution demonstrates this standard of evidence. One example of bias is the false assumption held by humans for thousands of years of the concept of the fixity of species. This assumption would not be questioned until the 19th century. In the 18th century, Carolus Linnaeus, the father of classical taxonomy and an expert anatomist, developed a systematic classification of the species according to their physical traits. To his astonishment, his system produced a nested hierarchy of species. Now, it never occurred to him that new species might arise by natural processes. Like his predecessors, he never questioned species fixity, and he was left unable to explain why humans are no less nested among primates than the other primates, why primates are no less nested among other mammals than other mammals, or why birds, mammals, and reptiles are nested together among the air-breathing animals. Linnaeus' system did prove useful to early 19th century naturalists, though. By the early 19th century, the field of paleontology was beginning to mature, and the anatomists of that generation now had access to a fossil record and also a rigorous discipline by which to classify their findings. What they found was that while the past indeed consisted of many mammals, reptiles, arthropods, and shelled animals, most of them were unlike anything alive today. Moreover, while they did not have a means of measuring the age of the Earth, they still noticed that the geologic column consisted of layers, and that these layers were ordered. Specifically, the fossil specimens appeared to be ordered in time in the same order as Linnaeus' nested hierarchy, with only the lowest taxa appearing in the lowest layers and higher order specimens only appearing later. Believe it or not, based on these findings, for the first time in history, the concept of extinction was introduced. And this finally demolished the idea of the fixity of species and the idea that all of the species have always existed. Now, the question naturally arises, if species fixity is false, then how do you get new species? There were a number of failed attempts at explaining this, but the first successful attempt was made by Charles Darwin, and his breakthrough theory was the origin of species by natural selection. His theory defined 4 key premises. They are 1, individuals of a species are not identical, and we can call this variation. 2, traits are passed from generation to generation, and we'll call this inheritance. 3, more offspring are born than can survive. We'll call this competition. And finally, 4, the variations of individuals give some members of the species advantages in the competition to survive and reproduce. And thus, those traits will be passed to the next generation. And this we can call natural selection. And the main point of this is to say that variation is innate to the reproduction of organisms, and new species occur when the environment selects for divergences in their populations. Since then, we've observed speciation many times, and I anticipate that the real disagreement with my opponent will not lie here, but with Darwin's next idea, which is common descent. Common descent by natural selection was Darwin's theory of the origin of species, and he now had a working model by which to interpret concepts like speciation, extinction, and the apparent order of the fossil record. To test his model, Darwin perhaps most famously predicted, according to his model, that there should exist a winged feathered animal with a reptilian tail, which was intermediate between birds and reptiles. And only 2 years later, Archaeopteryx was discovered, although it was poorly preserved as a specimen. As if that wasn't good enough, later, Ichthyornis, a beaked bird with teeth, was discovered. Now, the older Archaeopteryx specimen was too damaged to determine if it had teeth, but the Darwinists of the time predicted that if seabirds like Ichthyornis had teeth, then it was essential under the evolution model that Archaeopteryx should also have teeth. If it didn't, this would be extremely problematic for the theory. As it turns out, in 1877, subsequent Archaeopteryx specimens were discovered with indisputable teeth. Now, I'm running out of time, so I want to close my opener with the following points. 1, descent with modification by natural selection is the mechanism for speciation. 2, evolution is the only model which provides an interpretation of species flux, the fossil record, and extinction that makes testable predictions. And 3, these premises qualify evolution as scientific. And with that, I'll cede the rest of my time. Thank you.
Yeah, thank you, Ivo. And yeah, thank you, Ivo, for that opening statement. And I will present mine. So I'll keep both the screens here. That should be fine. And my opening statement would start now. So what we do see is a claim, an inference drawn upon natural selection to be true, mechanism of bringing out speciation and variation. So what we see is only observable evidence uh, learned through observation of the natural species, the chain of species or the tree of speciation. We see through observation that each of these species have resemblances to each other, and therefore we conclude it's very natural to conclude that they might have had common origins. So it's a very observable idea, right? But the topic of the debate is evolution premised on scientific evidence? So for that, what is scientific evidence? Is scientific evidence limited to observation? Partly, I might agree with that, but it does not fulfill the premises of requiring scientific evidence, which is testable evidence, right? So what we see and the examples that Ivo brought to the table is of certain intermediate species or intermediary species, which were predicted to have certain features to fill in the blank or fill in the gap. And so when we did find their fossils that filled the gap, therefore to conclude that is scientific evidence is to me a far-fetched idea. So what I would require as part of scientific evidence is evidence through genetic variation. So I would bring a subject to the table here, which is an example of fruit flies, for example. So we have two cosmopolitan fruit flies. One is Drosophila, and the other one is Simulans. These are two cosmopolitan fruit fly species. You find them everywhere. There has not been a geographical barrier ever in the world separating these two subspecies of fruit flies. And these two fruit flies have been the most studied in human history. Like the studies on these fruit flies go back to like 150 years right now, okay, or excess more than that right now. So Ivo, when it's about time for me to stop me, all right? Okay, don't hesitate to stop me because I lose track of time here while I'm speaking to you. So these two fruit fly species are cosmopolitan and they don't breed fertile offspring. So there are two subspecies. One would naturally expect them to breed fertile offspring because they're cosmopolitan and there wasn't a barrier separating the two as such, and they're very how do I say this? They have so much in common, but at the same time, you have endemic subspecies of fruit flies, like for example, from the island of Madagascar, right? So one of these two cosmopolitan subspecies, in fact, breeds fertile offspring with one of these endemic subspecies. But the one that poses a problem is the Melanogaster drosophila, which does not breed successful offspring that are fertile with any of the subspecies, even though Simulans and Drosophila, the two subspecies, have been cosmopolitan. And scientists who are researching this, they haven't really found genetic variation between the two, how the speciation really occurred between these two subspecies. So the fact of the matter is, there is no genetic evidence found by the scientists researching these genomes or chromosomes or base pairs of these two cosmopolitan subspecies. They have no scientific clue how speciation really occurred. What they see is observable phenomenon, and through their experimentation, they do find out that after some editing, they do breed successful fertile offsprings, but that requires gene editing, right? But by themselves, they do not produce fertile offspring, and scientists conclude they're perplexed basically. So Drosophila melanogaster and Drosophila simulans have posed challenges and remain unresolved in scientific inquiry. These fruit flies are intriguing not only due to their wide distribution, but also because they share common ancestor, making the evolutionary divergence of a subject of interest. So scientists have done significant work in this area, but they haven't really found genetic evidence that explains speciation to have occurred between these two subspecies, let alone the natural environmental factors to act on them to cause speciation. So that's entirely a different subject. They haven't even identified the genetic experimental evidence scientific evidence to establish speciation did occur. So the variations that Ivo is talking about from a common descent, we haven't really found scientific evidence, but what we do find is observable evidence. They are separate, they are subspecies, they don't interbreed with fertile offspring. We see that, but to realize as with the gravity of scientific evidence is what we are perplexed with. We lack the means to attain such evidence in our research. So therefore, I conclude in the most research genome of our lifetime for more than 150 years, we haven't really found scientific evidence. What we do find is observational evidence, which is inferred back onto science as if evolution has been the truth worked upon by natural selection, which I think isn't the case because we haven't really found scientific evidence. So therefore, I conclude my statement based on this. And yeah, we can now have a open kind of dialogue where me and Ivo would engage back and forth in understanding our substance that we have brought to the table. So what did you feel about that, Ivo?
Sure. So my first question would be for you to restate your definition of what scientific evidence is and what counts as scientific evidence.
So what I'm proposing is we need to find genetic evidence that leads into speciation.
So I'm asking a more general question about what is scientific evidence qua scientific evidence itself.
Yeah, scientific evidence is something that we find imprints that can be traced and tracked to see how the changes have really occurred. So what we see is there is a gap, and we see the appearance of distinct species, and we observe them, and we can also stumble upon their fossil records to find them. But what we do not see is the speciation occur at the genetic level.
So I'm not asking you what would be evidence for evolution. I'm asking you in science, in the epistemology of science and philosophy of science, what is the definition of scientific evidence and what counts as evidence and not? So I'm not asking for examples of evidence. I'm asking for what is the standard of evidence that would justify a scientific claim under the empirical worldview.
So any claim that would be testable, repeatable, and observable is what we call scientific evidence.
Okay, and so would you agree?
Or if you want to enhance the definition, I would be
okay.
keen to listen to. Yeah.
So in the first part of my opener, I had sort of described what scientific evidence is and also what standard of evidence is. Would you agree with my claim that what we call observations are theory-laden and subject to interpretation?
I did understand from you that you brought to the table of observation that we find in the nature, which can graduate to be scientific evidence. And then there's also this element that you brought to the table as well, that predictions to fill the gaps. And upon finding of those predictable outcomes, you sort of grounded your assertion or claim that these findings fill up the gaps and kind of standardize scientific evidence. Am I getting that correct from you?
So what I meant by that was not that I would not say that an observation in and of itself is evidence of anything. What I was really trying to establish was how we do epistemology in science, and the claim was that observations are subject to interpretation, and so an observation just by itself wouldn't be evidence of anything other than the fact that you're just experiencing something. And so the point of science as a methodology is to come up with interpretations that can distinguish your sensory experience from imagination. So you're trying to come up with a way to make what you're experiencing as objective as possible. Is that something you would agree with?
I get your point, but I wouldn't necessarily agree with it on the lines that there is so much scope for a prediction to come true. because there is abundance of species. We range in thousands and millions, hundreds of thousands species, and we can always see some commonality between these species, as is evident to even for a child, for example. So it would be very easier to predict something and to find, for example, an intermediary species. That on itself would not be scientific, because one of our predictions was found or discovered. I wouldn't necessarily call that as a scientific evidence per se. What I would say is we did some predictions and the predictions were realized. So we would be like heading into the right direction of investigation, but we still need scientific evidence which can be tracked, traced, and found to repeat. As in, for example, I will give you I will give one of the examples here, right? For example, there's something called as convergent.
Because
yeah, sure, go ahead. Go ahead.
Because the question I'm trying to ask is more general than this, and so what I'm really trying to pin down is the idea that so you have an observation, right, which comes in the form of a sensory experience, but the only way to have knowledge of the actuality, the objective actuality of what you're experiencing, is to have a worldview from which to interpret that experience. Is that something you would agree with?
Yeah, but why would you? I wouldn't necessarily call that as scientific evidence. I would call that as
so we're not talking about scientific
investigation.
evidence. We're talking about philosophy and how
Sure.
you have an experience, and the first thing you need to do to determine if your experience is objectively real is you need a worldview to interpret that experience.
Correct.
Okay, and so this debate is internal to science, right? And so we're investigating what is the scientific means of determining objective reality, right? So,
Okay.
so the first thing you need to do is you need to have a way of interpreting your observations, and specifically in science, the way you do this is by developing hypotheses and eventually developing theories. Correct?
Yeah, I would agree.
Okay. And so, if we extrapolate this to evolution, evolution would be then an interpretive lens from which to interpret our experience of the world. Correct?
Evolution would be one of those tools with which we can interpret. Because when you mention evolution, there are assumptions going into that.
Yes.
Mentioning of evolution. So we have to look at the merits of each of those assumptions, and there can be alternative ways of looking at interpreting the natural world as relates to origin of species and variations. So evolution can be one tool, I would agree with you, with which we can investigate based on the premises that we have found of evolution to work as a model. But there can be other theories as well, which could lead us in making a better sense of the natural world and how the species and how the biodiversity has come about.
Sure. So when you have a scientific theory like evolution, and I understand that this is the thing in question, but just nominally, I'm going to call it a scientific theory. It is making the claim that I think nature is like this. So it's an idea that says, I think nature is this particular way. And so this is the interpretive lens from which you are starting out when you look at nature. And so the question is, what would be evidence for this interpretation? And so that's really what I'm trying to make the debate about, is because the debate is evolution based on scientific evidence? And I'm asking the question, okay, well, evolution says the world is like this. What would be evidence for that? And what would be evidence for that under the scientific worldview would be testable, repeatable, falsifiable predictions.
I agree.
Okay. And so in my opener, I gave an example of one such prediction. Would you disagree that that is a prediction that fulfills the definition of scientific evidence?
Yeah, but we have graduated a great deal with our modern inventions. Like back in the day, like 100 years ago, when Darwin was basically making these observations. I should be really fair here, because Darwin is not the first person who did this. There's a guy called Ibn Khaldun, going back to the Islamic Golden Age. He's the one who proposed the speciation based on some of the verses which I'm aware of on the Quran, which he, I think, misinterpreted. So, and then we have Darwin. Obviously, Europeans got hold of these materials from the Islamic Golden Age, and Darwin, I think, learned of Ibn Khaldun's Origins of Species. And back then, the idea was holding good because they did not have scientific tools with them. They were observing things and they were drawing conclusions and inferences, which they were justified to do. Because, but today we have no excuses. We have scientific tools. We have great advancements in genetics, and that's where I'm bringing to the table the example of these fruit flies that are subspecies yet cosmopolitan. So the argument of barriers separating them into speciation is not even probable. So what gave rise to speciation in them needs to be found through genetic evidence or experimentation, and we have been doing that on them for quite some time now. It's 150 years in excess right now. We are perplexed. We have no clue. We cannot track genetically what separated them as two subspecies. But we do, what we do is we do modify, gene edit them into breeding successful fertile offspring, but we do not see in their genomes the trail of the speciation. What we do see is an observable evidence, like we observe them to be two separate subspecies.
Okay,
But
so
what we do not track is the genetic evidence of them undergoing speciation. So that's where my objections are. Scientific evidence has gotten to a graduate level right now. It's not at high school anymore that we observe things and make sense of it and interpret that to be with certain amount of confidence to be certain things, such as evolution by natural selection. But today we are in the graduate or postgraduate, for example. So we need more concrete evidence to conclude the sciences of evolution rather than just basing them on observable data.
okay, so I have a clarifying question then. So let me see if I understand the claim correctly. So the claim is that we do observe a phenomenon called speciation, right? Where they're no longer able to breed together. But you're saying that the genetics don't match what we would expect to occur if speciation has occurred. Is this sort of the claim that you're making?
Yeah. So I mean, that's what we would want to find. Like speciation occurs acted by environment, for example, but we need to have genetic trail. We need to see in species
And in your view,
a genetic trail of how speciation really occurred.
what kind of genetic variance defines the species barrier?
What kind of genetic variance finds the species barrier?
What kind of genetic evidence defines the species barrier? So
to be honest with you,
to say that this species is different from this species.
Speciation is a subject of debate again amongst evolutionary biologists themselves. They do not have a very black and white definition of what speciation really is, because for example, I can give you another example where for example, the African and the Indian elephants, for example, they do have phenotypic differences. Some of them are quite major and some of them are minor differences, but the fact that they were brought into copulating and producing offspring, the offspring that was born to an African and Asian parent did not survive. It actually died. So we do not ascertain whether the offspring was in fact fertile or infertile. That's besides the point. The offsprings do not survive because there is some strong differences between the two elephant categories. For example, the Asian elephants, the pregnancy term is shorter than the African elephants. So there is some fundamental difference between these two species, but yet they were able to produce an offspring. But I'm not sure whether we could ascertain whether the offspring was fertile or not because the offspring died out. So the definition of what is a different species is really blurred. Like it's on the gray scales, not really black and white.
Okay.
So, but the natural expectation that I would bring to the table from this point of view, an argument on African and Asian species is this. It might be also helpful for you to listen to this argument and then think about it. There is
Well,
something called as
before you
convergent
make a new
evolution.
argument, if I can address what's already been said.
Sure.
So, yes, I do agree that it's fair to say that the species concept is a little bit fuzzy, and it's perhaps not a scientifically rigorous concept. So, in modern biology, we've developed a concept called monophily. Is that a concept you're familiar with? Monophily as opposed to polyphily or polyphyletic.
No, just go ahead and explain even for the audience here.
Okay, so now we use instead of species or like the old Linnaean taxonomy system, we use a system called cladistics, and clades are defined by a concept called monophily, which says that related or organisms which are related to each other, the way that you can define them is because traits are inherited, right? Traits are heritable. Then members of the same species or the same clade there should be some suite of traits which all of them have, which is diagnostic of that species, but also traits which only that clade has and nothing else has. So there's a combination of traits which all of them have and only they have it. And this is the way to distinguish between clades. This is how you can actually define a clade, is through this concept of monophily. Does that make sense?
It does make sense, but it's not, again, an absolutist kind of measure.
It is.
Because do you think
I would actually make the strong claim that yes, it is.
Yeah. Okay.
Because
why so?
Because
can you give me some live examples?
Well, I'll give you general examples first. So right, because monophily is like a theoretical concept for defining clades, and it has entailments. So one entailment is that, so if you have these traits that define a clade, well then and this is the case whether macroevolution is true or not, necessarily logically that there must exist some ancestor which also had that suite of traits. It is logically necessary that this existed, because traits are heritable. So if individuals share heritable traits and they're the traits that only they have, well then they must have received it from common ancestry. And again, this is not to make a macroevolution argument. This is saying within a clade that we can actually say are related species, say they're species, and we can observe them breeding. The only coherent way to define a clade would be via this concept of monophily.
So you're telling me the common ancestor should have had all of those traits, and the descending species would inherit some of those, and other siblings would inherit some of those, and they would go on to retain those traits specific to them, and that's how speciation sort of occurs in what do you call clade? Is that what it is?
Clade.
So the ancestor is assumed to have all of those traits that the descendants have. So are you making a claim that the ancestor should and must have all of those traits?
So it's an if-then claim. So if the species is a clade, right, and so this would be the assumption part. The assumption part is the idea that it actually is a clade and it meets all the criteria for a clade. The claim is, if it is a clade, then it is logically necessary that the ancestor also had all those traits.
Oh, okay.
And then because it's an if-then statement, this is a testable, falsifiable claim that you can actually go out in nature and try to observe.
Don't you think it's counterintuitive, because it would somehow inhibit evolution of new traits? Because just because the ancestor did not have it, it's counterproductive or counterintuitive to the very as to the very proposal of uh, evolution theory, because that sort of inhibits uh, s- um, offsprings to develop new traits
So
based on their environment.
the reason that's not true is because monophyly is not defined on an individual by individual basis. So sure, you could say that some individual is entirely unique compared to all other individuals, and so it would be pointless to define a clade on the basis of that individual. The reason your claim doesn't work is because it's saying every member of the group has all of these traits, so it defines all of them. And
Okay,
if there
but
was a mutation where there is a new trait, well, then all of the descendants of that individual that has that trait, that would be, well, it wouldn't necessarily be a new clade, but potentially there could be a new clade that is defined on the basis of that new trait. It would be diagnostic of the descendants of that ancestor.
okay, if you are okay with it, like I would like to bring a new example
Okay,
to be discussed on this around this subject matter, monophyly and clade. Right? Are you okay with it?
sure.
Okay, let's talk about this. Let's talk about the migration of elephants from Africa into Asia. Okay. So what we do see is some noticeable phenotypic differences, such as the toes of the African and Asian elephants. The Asian elephants seem to have one extra toe on fore and hind limbs, and African elephants one less toe on fore and hind limbs. And African elephants have double fingers on their trunks. Asian elephants have just one finger, mostly the top finger on their trunk. And let me just focus here because there's several other differences between the two elephants, but just let me focus here so it's easier for viewers to understand the subject matter. So suppose if the ancestral elephant that drifted from Africa into Asia with both of the fingers on the trunk, right, eventually loses one of its fingers, the bottom finger on its trunk in Asia, why would that necessarily give way for all of the population to just have one single trait in Asia, which is just to have the upper lip? Why wouldn't there be a proliferation of species in Asia which depict two fingers on trunk on some elephant groups and some elephant groups to have just a mutated difference show up on their trunk, which is just the upper lip, upper finger on their trunk? Especially when you take the view of natural selection acting on this species, which is, for example, the difference in geography and climate. That's the only difference between the two regions, African and Asian. But in Asia, for example, you also see a terrain very similar to Africa. For example, the northern India does have a terrain that resembles the terrain and climate of Africa. You have this desert in northern India that very much resembles the conditions in Africa, and you also have regions in Africa such as Botswana, which is very wet, rainy, dense forest, bushy, soft soil, and the Kilimanjaro plateau and the mountain in Africa resembling the southern and the eastern geography of India. So when this ancestor did come from Africa into Asia, it has conditions that it has been used to before and or having lived before, and also conditions that are new or geographies that are new. So what I would naturally deduce any mutation to happen would be typical to newer geographies, and that in itself should not cancel out speciation, that we must be able to find both of these group extant in India, for example, elephants with double fingers and elephants as well with single fingers. Why do you think, or how do you think, clade and monopoly sort of uh, what do these concepts in modern biology go on to explain for what we do not find to have happened in the Asian elephants?
Okay, so I heard that the question is why would if one elephant develops a particular jointedness in its trunk, why would all of the subsequent ones necessarily also have that jointedness? And then the question is, why would they not instead experience this proliferation of forms, as you have described, across geography? So the first clarification I would make is that the proliferation of forms claim is the correct thing that we should expect to happen, not the necessarily be all derived from one trunk thing. Monophyly and clades it pertains to definitions. It pertains to saying that the ancestry of any two individuals is knowable. So this is a model for saying that the ancestry between two individuals is knowable, and it's knowable by their diagnostic traits, which are the ones that I described before. We would definitely expect a proliferation of the species. And I do have a clarifying question for you. Is it your view that the different species of elephants share a common ancestor? That they're all the same kind?
Yeah, my personal view would be speciation do occur from common ancestor, but not in a way acted out by natural selection. I would infer an agency who would bring about these variations in species.
Okay, so I think this is probably a great place to take the debate then. So in my opener, I'm going to go back and read here. I quoted the four key points that Darwin made. Let me see here. I can just name them for brevity. So they were populations consist of natural variation. Traits are heritable. Individuals experience competition. And due to that competition, those with more favorable traits are selected upon by nature. Do you disagree with any of that description of populations and reproduction?
Okay. I'll have to say this. My disagreements are in the processes that lead to variations, right? So the evolution side, the group that sort of proposes evolution might argue that these are realized after millions of years in how the environment would act on the species and carve an entirely new different species, right? So that would be the argument that the evolution side of the table would bring to the table. But I would disagree with that. I would say these were intended, designed, not so much that and naturally worked out after millions of years, in which I would ever increasingly expect more proliferation to have happened, and more genetic tracks and trails to be left, which would assist us in finding that exact scientific evidence that would go on to then clarify to us that indeed speciation really happened, because we can see the genetic blueprints, the genetic trails of how species really diverged and what sort of factors from the environment acted on them. And it all makes sense that these factors acted on them, and we realized these subspecies because of these exact forces acting on them. And this is how the phenotypic characteristics have evolved in response to those stimuli from the environment, right? So I would necessarily argue, if an agency was not involved, I would argue there had to be more proliferation of subspecies, especially in this trajectory that we see from African elephants into Asiatic elephants. There had to be a more proliferation. In fact, elephant groups in India should have resembled some of their ancestors in Africa, which is not the case. And we don't even genetically, we are not even able to point them out through their genetic studies. For example, the Drosophila, the fruit fly genome, is very small as compared to the elephant genome. Elephant genome is as big, at least as big as human genome. In fact, they have 56 chromosomes, and their base pairs go up to like 3.2 billion. And just like human genome size, base pairs are like around 3.2 around there billion. But the genome of a fruit fly is pretty small. It's like only 8 chromosomes and 180 million base pairs. So when we are having such a big trouble figuring out genetic trail in what caused speciation between the two cosmopolitan subspecies of the fruit flies, you can imagine how difficult the weight of evidence looms on us or burdens us to be able to dig that out for elephants, and especially with the assertion that if you go back to the elephant groups, the common ancestors, we get to hear a story from biologists, evolutionary biologists, to say that they infer elephant has had common ancestors with hyraxes and with sea cow. Again, there is such a big gap to be filled in terms of what scientific evidence could go on to explain that kind of a trajectory for elephants to have come about from a common ancestor there with that group of animals. We are having to battle very hard with even with the tiniest of the things, that even one claim. I mean, I would necessarily bank on just one assertion to come true in a scientific way for me to embrace the idea of evolution by natural selection to be true. I would postulate that natural selection is in fact an intelligent agency. It's not this random naturalistic forces in the environment and geography and climate that are acting on the species, but I would infer that natural selection to be an agency, an intelligent agency, which I would call a creator, a designer god, that goes on to bring about variations among species, and that's how he has brought about biodiversity in the world, not necessarily from a common ancestor, not necessarily from a common ancestor. I would not say all life found is the result of one single cell that sparked. I don't hold on to that view. That's just a ludicrous view in my opinion.
So
I believe life.
So let's go back to the
Go
elephant
ahead.
thing before we go on
Yeah,
to origin of life or other topics.
yeah,
So
yeah,
the
yeah.
idea of design in selection, I think, is a great topic for us to go to. As an aside, because you said a lot there, I would say if you are expecting this vast proliferation of elephant species based on based on like the sort of variances that we see, I would encourage you to look at the fossil record and see that there are actually dozens of species of elephants out there. And in fact, we actually have genetic evidence we actually have the genome of woolly mammoths. And we were able to determine that that woolly mammoths are actually more closely related to Asian elephants than Asian elephants are to African elephants. So we actually do have this proliferation of elephant species that is well documented. I wanted to go
But
to
not in a way that I'm actually trying to imply. I do know of woolly mammoths to have existed, and their familial ties with the Asiatic elephants. But what I'm trying to say to you is that I would naturally expect proliferation in elephant groups to be extant even today. I mean, India, for example, is a big geography. Like I can give you a convergent sort of evolution example. You
I'd
have
like
also the
to
African.
continue my line of questioning first.
Sure,
Because I had somewhere I was going with this. So the first question I had for
gotcha.
you was, do you believe in the concept of adaptation?
I think I clarified to you what I am, where I'm having my objections. My objections are uh, species adapt no matter where they live, but those adaptations don't infuse new traits. New
Okay.
traits are being ushered in instead of being like acted upon by environmental forces in getting that response out of that animal. It's basically ushered in, and the response of the animal in that particular um, geography results necessarily in that trait because that trait was ushered in rather than worked upon intelligently in an intelligent way through natural selection.
Okay, we can go in this direction then. So on the idea of advantageous traits being designed, I would say that, well, one thing about adaptation is, one, we observe this thing called natural variation, and again, I understand that calling it natural variation is begging the question of the topic. But what I mean is, individuals are unique. This is one of the points that Darwin pointed out, that there's something about reproduction where every individual is unique and not the same as other individuals. So we have this on an observational basis. So I'm not saying I have an interpretation of why that is. I'm just saying it's a fact that every individual is unique. When you have an adaptation, which refers to like some kind of favorable trait in the environment. This means that it is context dependent. It's dependent on the context of the environment. So if you take one gene for some given trait, maybe it reproduces really well in one environment, but if you take that animal and you move it to another environment, you would call it like a very maladaptive trait for that environment. So the point I'm making is that the definition of adaptation is very context dependent. Now, if you want to go into teleology and purpose and design, I would say that in addition to variation, I keep calling it natural variation, but a variation being inborn, is we also have all of these forms who don't survive to adulthood, right? We have all of these mutations. Some of them lead to what I would call adaptive traits, but many of them, in fact, perhaps most of them do not. And we have all of this death, which is involved in the evolutionary process, in the diverging process. And so to me, it seems that what kind of mutation you get is really up to chance. It's not really directed, because if you're going to say that adaptations are purposeful, well, you would have to say that all of the maladaptive traits are also purposeful, because it's the same process of reproduction which is producing both of these phenomena.
What I would like to say here is this: the genomes of species have elasticity in them, and this is a part of the design that God has sort of organized. For example, if you go back to human species, I mean, human beings are one species, we understand that. And if you go back to the scriptural premise that human beings had one parent, Adam and Eve, for example, and they had kids, and we then see a proliferation of variations among human beings. So human beings that went to China, they look like Chinese with, say, different features, like their head shapes are a little different, their eye shapes are a little different, their noses are a little different, very different from how the Africans would look like. For example, the African colors are different, the nose shapes are different, the skull shapes are different, the body shapes are a little different. So human beings originally had elasticity in them. So when they go to new environments, the elasticity responds to that new environment and develops phenotypic traits typical to that geography. So this is within the design that God has brought us about in. So once the proliferation happens, once the genes acquire traits based on the new environment, they would not revert. For example, if you then bring Chinese into Africa, no matter how many generations you reside them in Africa, they would not reacquire traits based on the African environment. So once you acquire, the elasticity freezes. So the designer has this natural way of elasticity within the genomes to respond to different geographies on the globe, and they acquire. Once these traits are acquired, they become immutable. So that's where I come from, and I see variations to happen from this premise, and that's how I would see natural selection. In a way, if you want to say, acted by environment does occur, but it's in an intelligent way. It's the allowance is there within the genome to respond to the environment, not necessarily that the environment itself intelligently carves out new mutations and new traits that are advantageous, not necessarily in that manner, but the elasticity is found within the genome to respond and to collaborate with the geography and the environment around it. And once acquired, they become heritable and they become permanent.
So the environment does not have a creative capacity to create new traits, right? So I draw this dichotomy between what I call generative sources of variation and reductive sources of variation. And the environment would be the source of this reduction. It's taking what already exists, and it's culling what we would call maladaptive traits, right? And so what is actually the creative generation of new traits would be from the genes themselves, right? Genes cause traits. And what you're referring to as this elasticity of the genetics to produce all of these different forms, I think in the evolutionary review, we would refer to this as the concept of genetic drift. This is to say that, well, every trait is some combination of a string of nucleotides, right? There are four base pairs in DNA, and it is the arrangements of these base pairs which cause all the variations that we see in nature. And I lost my train of thought of where I was going with this.
Take your time. Take your
Okay.
time.
So yeah,
Take your time. Absolutely, no worries.
yeah, so okay, I was addressing your idea of the elasticity of the genes. So the first point was that any given trait is going to be some combination of genes, and so if you look at human groups specifically, because that was your example, we do have what you could call phenotypic traits versus ethnic traits. So a phenotypic trait would be something which actually refers to adaptiveness in a given environment, right? So like dark pigmentation in Africa is adaptive for protecting against UV radiation from the sun. But there are other traits which are particular to people from around the world, which are ethnic traits. And they have no particular reason why they're.
Can I stop you? Can I stop you here for a minute? Can I stop you for a minute here? So I did read Richard Dawkins, and I thought he made some very loose arguments in his book. And one of those arguments would be this: that Africans developed darker pigmentation to respond to the UV radiation. But I'm of the opinion that the UV radiation is the strongest at the poles rather than at the equator. We have a pretty good blocking out of the radiation because the sky layers the planet Earth has are the thickest at the equator, and they are the thinnest at the poles. So another argument that Richard Dawkins brings is in explaining how human beings lost their hair from the primate background. Like primates do have a lot of body hair, and human beings tend to not have them. And Richard Dawkins sort of, I think, if I'm right, had said, because humans started wearing clothes, we lost the hair. Well, that's again a fallacious argument, because we have worn clothes on our lions a lot more than on our bodies. But the hair of the lions somehow is dominant in human beings, not so much with the primates. The primates don't even have hair on their genitals, but human beings tend to have a lot more hair on the genitals than have hair on their body, which they basically kept exposed for a long time. So these are fallacious arguments. I don't necessarily buy them as substantiating any claims of evolution, because as we see, the factual data is quite different. UV radiation is ever more at the poles of the Earth because the sky layers thin out at the
so
poles.
I definitely want to address that.
Yeah, sure.
And as an aside, I wouldn't say this is evidence, but my personal view of why humans are hairless is to make is to increase the efficiency of sweating for a heat reduction. But anyway, that's a tangential point. I'm going to go back to this idea of UV radiation being worse at the poles. This is simply not true. So it might be the case that the Earth's protection is weaker at the poles. So like maybe there's less atmosphere, maybe there's a weaker magnetic field at the poles. But the actual sun rays are most direct at the equator, and they're the most intense at the equator. The other thing is when you go further north, and by the way, Europeans and Northern Asians are not from the Arctic, they're just from the north. These are areas that experience more seasonal variation. And so for half of the year, the sun is covered by clouds. And so they actually experience much less sun overall. But also, because I'll let you address that. But then I had something else to say back to
the thing is,
what we were talking about genetic
I have
drift
no
and ethnic
objections
traits.
there for reasons that are valid. For example, like you also have these dark-skinned people live in the south or live in the poles, even north. For example, people lived in Canada who were Red Indians, and people also lived in the south, in New Zealand and Australia, Tasmania, and New Zealand. So people have existed. Dark-skinned people have also been part and parcel of those geographies for a very long time. I think these people who went to Canada and New Zealand were migration herds who migrated much before that Europeans went into Europe. So if you go back to history, human migration to these lands have been predating migration into Europe, for example. So it all colludes to these um, conundrums and quandary to really attribute environment to play a significant role if you do not address the elasticity available in the genome kind of argument that I'm bringing to the table. So what I'm saying is, once people go to these, once elasticity has been addressed or adapted to a certain situation, then you can't. It's permanent. You cannot they don't undergo the process of adapting all over again. So they are permanent.
So in the case of Arctic peoples, the first point I would make is, one, they're not nearly as pigmented as equatorial Africans are. Two, when you look at peoples who are not like in the extreme of the Arctic, but are in the intermediate zone between the equator and the North Pole, these are people who live in climates that experience a lot of seasonal variation. Whereas in the Arctic and at the equator, you experience much less seasonal variation. And in those areas, people tend to have lighter skin. I'd also say that Arctic peoples, unlike Africans, a lot of their pigmentation can be explained not by actual melanin in the skin, which is the skin pigment which darkens it, but actually adipose tissue underneath their skin, which is like a fatty layer, which like serves as insulator in the cold. And so a lot of their pigmentation actually is not from melanin, it's from other sources.
The fact of the matter is, the equator is just not limited to Africa. The equator runs through the globe, through the Middle East, Asia, and parts of southern China, and the South America, for example. But you don't see similar phenotypic traits emerge in peoples living there. So it's basically not the environment so much that's playing the role. It's the elasticity within the genomes that gives rise to these different phenotypic and ethnic triads, so to speak.
So there are 2 points on this. One, the archaeological evidence is that Africans have been in Africa for much longer than Amerindians have been in South America. And two, this actually comes full circle back to the point I wanted to make about genetic drift and the existence of ethnic traits. So it seems to me that, yes, there are some traits which are pertinent to the environment. And again, I cited pigmentation. I know you disagree, but there are also traits which seem to have no pertinence to the environment, which are the ethnic particularities. So for example, why can you tell the difference by looking at them between, say, an Armenian and someone from England, right? Purely on the basis of ethnic or like skull features or hair type. Doesn't seem to be an adaptive reason for this. It just seems to be variation caused by genetic drift and natural variation.
I think we have things to talk here in this area to go out a bit more detail and work this out within human populations. Like, for example, Chinese look a certain way, Indians look a certain way, and Indians do look like Americans a lot right now, but Americans have been migrants from the Europe into America. Not so much. Indians don't look so much like the Red Indians for some reason. Indians, like as in India as a country, people there do not resemble Red Indians of America, the Comanches, or or of the Canada, indigenous populations in Canada. And Indians don't even look like the Aborigines of Australia, for example. I do find some resemblances from Sri Lankan people and the Aborigines of Australia, but still the Aborigines of Australia is very different from Sri Lankans, for example.
And so my question is, why don't they look the same?
Yeah, that's what I'm saying. So my answer to that is human genome has the design of elasticity in it. And once it acquires new traits based on new geographies, those traits become permanent. And they are not really worked upon by the environment, so to speak, because if that was the case, then necessarily the Canadian people, the indigenous Aborigines people in Canada, although you argue that they have less of a pigmentation, but they still are not white, for example, like Europeans. What prevented them from becoming whites will then become a question that probably you need to answer. And so there are things like that which we can go into detail for sure. And
so
yeah, I would be
what I'm
interested
saying,
in. Yeah.
What I'm saying is that what I'm calling ethnic traits seem to have nothing to do with the environment. They just seem to be natural variation for no apparent adaptive reason. It's just that, and so I do partially agree with your idea of genetic elasticity. I wouldn't call it genetic elasticity. I would call it genetic drift, where we agree that traits are caused by genes, and there exists. Well, maybe we don't agree on mutations, but I would say there are mutations such that this is the driving factor that causes individuals to be unique. And a very common thing in evolution is that you can have what's called fixation. You can have fixation of traits which have no apparent adaptive purpose. They're just kind of neutral, and just kind of over time, as populations are no longer mixing with each other, they just acquire what I'm calling ethnic traits, where there's no apparent reason for it to exist other than just over time, variation increases.
Mm.
But it's not geography or context dependent.
No, all of these reasons that evolutionary biologists bring to the table, most of these are, say, inferences, more so weakly supported. Because even the sweating issue that you brought about, we lost hair because we want to profusely sweat and cool down, is like we still should have not had hair in the underarms, for example. That's where we have hair. We can't get rid of those hair, and that's where we sweat the most. So the thing is. I'm sorry, I lost the thought that I wanted to say, and yeah, bringing the debate back to the original topic, is evolution premised on scientific evidence. So what I go on to postulate and or emphasize all over again is, we see observable variations everywhere around us and within us, and we try to attribute this to a theory of evolution by natural selection, without an intelligent force behind this science, or behind this theory of natural selection. Here is my objection. My objection is, we do not see in the genetic drifts or genetic variations any evidence that points at, in a scientific manner, points at these variations to be a result of naturalistic forces acting on the genes. But what I do see is an inference drawn from observation, and that is not conclusive to me to be reckoned as the best scientific evidence. So, I mean, this is the debate topic: is evolution premised on scientific evidence? And I would argue that we do not come across scientific evidence in the form of studying the genomes of species to cater for, or we do not even see the trail of these genetic variations worked out by natural selection in a very predictable way. You know what I mean? So that's my objections to the debate today, and I think I need evidence, scientific evidence, to be able to believe in the premises of evolution by natural selection to have been the case, without involving an agency that's intelligent, that's providing the elasticity within the genomes of these species to collect and retain variations.
Okay. So I think I would grant that the most recent topic that we've been discussing on this subject of whether there is accidental variation or whether there is purposeful variation, for the duration of this topic, we haven't really discussed scientific evidence as such. I'll go back to my original argument about scientific evidence, which is that the evolutionary interpretation, and I think we were able to agree that science is interpretation based. You have to have an interpretive model for your observations. Is that the evolutionary interpretation, and only the evolutionary interpretation, is capable of making predictions about what we actually see in the world and what we would see in the world in the future. Now, I do still kind of want to talk about this idea of purpose or design in variation, because it seems to me that if we go back to my idea of generative sources of variation, well, it seems that whatever is generating positive variation is also generating negative variation at the same time. So if you have a purposeful interpretation of this, it seems that you would almost have to say that all of the death and non-function, dysfunction, and suffering are just as purposeful as anything else, because the things that make individuals unique, these generative sources of variation, seem to cause all of the spectrum and not just the adaptive stuff and not even the ethnic stuff.
So can you reassert
So
what you just said, please?
so there are two important things to consider, which is that under the evolutionary interpretation, we make predictions based on generative sources of variation, which we interpret to be unguided mutations, and reductive sources of variation, which would be natural selection, taking the variation that already exists and reducing it so that only non-maladaptive traits retain or fixate. And what I'm saying is, whatever is causing new traits, and we can go to ethnic traits if you want, if you don't want to talk about adaptation. Whatever is generating the variation is also generating a lot of bad variation. And so on the view that the source of the generation of variation is purposeful, it seems like you would have to concede that it's also purposely creating a lot of bad variation.
So give me one example with which I can relate to, and we can then weigh the pros and cons of this good advantageous triad and its negative impacts, deleterious impacts. So give me one example where I can relate to this very well.
So it seems to be the
so
case
I can
that there's
see
a lot
the
of
deleterious triads and the advantageous triad and how they fare.
It seems to be the case that there are a lot of genetic diseases, for example, and prior to modern medicine, this resulted in about 50% of children dying before reaching adulthood.
Sorry, can you please rephrase that? I was just writing down here.
Yeah, so you wanted an example of deleterious traits, and I cited the example of genetic illnesses, which prior to modern medicine typically resulted in infant mortality. And this would have been a trait that they're born with, which would have been maladaptive to their survival.
So what good triad assured in these negative triads, negative or genetic weaknesses? Or
you're asking what good traits are in the genetic weaknesses?
Yeah, I mean, you did say the advantageous triads do result in deleterious outcomes as well.
Right? Oh no. That was not what I was saying. So I was saying that in generative sources of variation, you get good and bad, whereas in reductive, you're just eliminating the bad and keeping the good. So I'm saying that on the view that the variations that we see are designed on purpose, well, it doesn't seem to be a way of distinguishing the source of good traits versus the source of bad traits. It seems that they're all inborn.
Yeah, okay. I mean, I don't see that as a necessary problem why a designer, for example, should not induce weaknesses in the gene pool, because the designer has a teleological framework to organize his purpose on planet Earth, for example. So if he has deemed, or if the intelligent agency has deemed that species do need to have reductive traits where they face mortality or a range of disease, if that's been the plan, then that's been the plan. So I don't necessarily see that as any good objection why a designer necessarily should only grant generative traits or not, and not reductive traits, for example.
So I think it's fair to say that there's that there's, as you said, not a logical contradiction there, and that this is the way that the creator brought about the variation of the species. I guess in response to that, I would pivot to, again, this concept of falsifiable prediction. And so if you go back to my original point, the point was that on the view that trait generation is the result of mutations, this actually predicts how speciation occurs. And the way you can map this is, again, if you go back to like the concept of monophyly, you go back to the concept of fixation. It seems that it seems that you can draw post hoc a distinction between traits which were adaptive to their environment traits which were neutral to their environment and a result of genetic drift, and traits which were deleterious to their environment. And this model can explain speciation, and it actually predicts species both in the fossil record, and it also predicts certain outcomes that we can observe in the genetics of species.
Okay. Can we at least agree? I mean, I don't want to conclude this debate in a way that's not progressive. You know what I mean? So can we at least agree? I mean, what I meant was I don't want to conclude this debate as going one or the either ways. I want to be advancing this debate to a new level. So from this premise, can we agree that we can go back and next time talk about what has been preventing human beings or our researchers, evolutionary biologists, in identifying the genetic evidence of speciation between the fruit fly species that are so thoroughly researched? So what's stopping us from getting at the sort of genetic evidence we would require to conclude speciation?
Well, I would say right now that I am confident enough in my worldview that even though I'm not familiar with the fruit fly example, I would bet you that if you looked up monophyly, you would find a monophyletic distinction between the fruit fly species that you were talking about, and that would be the genetic distinction that exists. So I'd actually make the bet that it does exist, and if you research monophyly, you would find it.
In my understanding so far, we do not have a track or a trail of how these subspecies, which are two cosmopolitan subspecies, a genetic trail of their separation. I think we don't have it. Okay, I will check out, as you said, monophyly about on this particular example, and try to see what has been the conclusion drawn, what has been the evidence that's been sequenced from their genomes that goes on to explain their separation as two distinct species. But I would also want you to do some work there, and we can talk about this as a next subject in getting at the exact scientific evidence that explains us how speciation really occurs.
Well, I have a question for you, because I sort of put myself out there, and I made a prediction for something that I don't know. And so my question for you is, if it turns out that I'm right, would that be scientific evidence, or the definition of scientific evidence that my model understands something? That I'm actually understanding something real and true about reality? If it turns out that I'm right in my prediction,
you can say so, but
I'm asking you.
Yeah, you can say so, and you can be. I think you can take some pride in it because you predicted it and it's come true. But what I'm interested is not your prediction coming true. That's not my interest. My interest would be to look at whether there is genetic evidence of speciation to have occurred. That would be my interest, and if there is, then I would embrace the evidence that's found.
So I would say the scenario described is genetic speciation, and I would also say that what I described is the definition of scientific evidence per the debate, or an example of the definition of scientific evidence.
Yeah, I do see where you're coming from, like predictive models to be graduating at scientific evidence. But again, I would like to say to you, predictive models are good. You can lean on them. They can be your tools, but scientific evidence is still separate from predictive deductions.
Not really. They're basically the same thing, and this would be a problem that every scientific theory in existence has.
Because again, look, as I said, predictive findings can be interpreted either ways. It can be interpreted citing to cite certain assumptions. You say evolution by natural selection, group 1, or it can also be interpreted to say, for example, group 2, where I postulate genetic elasticity and acquiring of permanent triads. So
Well,
it could either way be interpreted in one of these models. But what I would require is scientific evidence, which is not really predictive and uh, deducible, but a really
I think we disagree.
intertwined within the genomes of
I think we
species.
disagree on where the interpretation is occurring. So I agree that there is interpretation. Specifically, where the interpretation is evolution is the interpretation prior to the prediction being discovered. So we're saying that evolution, and this is again, this was from my opening statement. Evolution makes the assumption that the world is some way, right? And so that's where the assumption is happening. The interpretation is the assumption, and you're making the assumption before you make the prediction, because the assumption entails consequences in the world. And so if the consequences in the world are the way you assume them to be, that's a prediction, and that's scientific evidence.
What I would say is the predictions are very trivial. They are not at a graduate level, and I would go on to say I would go on to demand graduate level predictions. For example, I would say, okay, if Asian elephants did converge into some separate traits from their African counterparts, and we do know that lions did make out into Asia from Africa, and I would sort of demand convergent evolution to also have happened within the lion populations. But today we see it's not so much the case. Lions in Asia and Africa do create fertile offspring, but it's not so much the case with elephants. So I would say make predictions at that level and see if convergence can yield those predictive models can yield um, results that you would go on to expect, at a higher level than just making trivial predictions, which obviously can be seen because of the immensity of the stage, in terms of thousands and hundreds and thousands of species. I also made a prediction. I made a prediction in my book for some dino species to have oozing out milk from their chests, and I also made a prediction in my book for um, leopards, for lions to be equally good tree climbers, and I realized it after I wrote my book just recently. I mean, I wrote my book 7 years ago, but recently I got to know there are tree dwelling lions that
So
very much
I have a
resemble
question for you.
leopard like habit. So yeah.
If it turned out that lions were not good at climbing, or if it turned out that no dinosaurs had memories, would that falsify your worldview?
Not necessarily. I'm just making a prediction. That's what I'm saying. Evidence has to be scientific. Predictions can be observable. They can come true or they can come false. And
So
I did come across lions that are tree dwelling, for example, right? You might argue they are not as good as leopards, but that's a separate argument. But there are tree dwelling lions.
I'm fine
There
with
are.
granting that. I was asking more of a
Yeah.
philosophical question
Yeah.
of is this a
Yeah.
falsifiable prediction, or is this just like a guess and you got it right? But
No,
the point
because
is,
no, I'm where I'm coming from. Where I'm coming from is obviously I'm a human being. I have my own limitations, right? So I'm not playing out a prediction stating this had to be. I'm laying out my predictions based on my observable knowledge, which I kind of grant that I can be wrong. You know what I mean? So I don't base it on entirely my observable um, predictions as the criteria. But what I would say is I'm more inclined to take a robust piece of information as my evidence rather than just observable claims.
so this brings me to the other part of the definition of scientific evidence. So it's not just that you predicted it, but that your prediction is falsifiable. So if you found a different result, then that would prove that your worldview is wrong, right? And so you give me examples of unfalsifiable, or even if they are falsifiable, that they don't have any bearing on the validity of the worldview. And so one example I gave in my opener was the Archaeopteryx example. The first Archaeopteryx that was found, they weren't able to get a good look at its mouth, and they couldn't see if it had teeth. So they had to be agnostic as to what its mouth was like and if it had teeth. But later they found birds, which were in higher layers, so they were younger than Archaeopteryx. And these birds had beaks and they had feathers and they had wings, but they had teeth in their beaks. And so the Darwinists of the time, they reasoned, well, if if Archaeopteryx is more primitive than these toothed birds, then necessarily Archaeopteryx has to have teeth. And if Archaeopteryx doesn't have teeth, then unequivocally evolution is false. And so they made a very bold claim, and this is also why this counts as evidence, because it's falsifiable. It could, not only could it be wrong, but like the theory hinges on it being right.
Yeah, I'm not a fanatic, so to speak. I don't make those claims, outlandish claims, even though I made some predictions in my book just to sort of open the box of reasoning and rationale, like how easy it is to make predictions and realize them to be true in the
It's harder to make
plethora of
falsifiable
life found on
predictions.
Earth. Sorry?
It's much harder to make falsifiable predictions, such as that Archaeopteryx necessarily should have teeth. There's no way for them to have known that unless they assumed evolution.
I think it's fairly easier to make the prediction, to be honest with you. It's not something that's outlandish in
And
the
would you
plethora of
say,
life that we find on Earth.
and would you say, because you said you're not a fanatic, would you say that the standard of evidence for a view being that it makes falsifiable predictions, would you consider that a fanatical view?
I would say so, because even the assertions that some of the atheist evolutionary biologists make, for example, oh, human beings started wearing clothes, that's why they lost the hair. And then they're forced to change that position in the future, but it's already said and done, it's already recorded, and people know of those arguments to be truly made by a biologist. And once we realize them not to be the conclusive sort of argumentation, so why we lacked hair, then I mean, those evolutionary biologists don't concede the argument. They would say, oh, that was my best guess back then, but now I have a new prediction because science is advancing and blah blah blah. So I think these sort of predictions are never true to the core, and I understand that. I grant it to evolutionary biologists. I mean, I don't hold those sort of argumentation as a defining evidence why they have to let go of their claims of evolution or anything like that. I'm more so keen on graduate level evidence. Like, for example, I want evidence to come out of our labs, come out of our genomes sequence. We do a great deal of genome sequencing these days. We also go on to edit these two fruit fly species to produce fertile outcomes for their offspring. So when we have so much leverage in analyzing their genomes, I'm banking on seeing speciation occurring within the genomes. I want a trail. I want a track record of how the genomes have facilitated subspecies based on the environmental factors. So I'm more so looking at a higher level of evidence than just observations or mundane predictions, which can come true, which can be of which won't come true. I mean, I made my predictions in my book. That doesn't mean that if they are falsified, I'm going to change my opinion, because I'm not making those definitive predictions as if they are going to define my beliefs. No,
but that's what makes it
the predictions
scientific.
I can understand. Yeah, I'm more keen on looking at the scientific evidence to come
that's
alive.
That's what I'm saying. So,
in
order for it to be scientific, it necessarily, if your prediction is false, then your theory is wrong, right? And so, I think basically when you're saying that standard of evidence is a fanatical view, you're basically calling science fanatical, because that's what science is.
So how will you answer this? Richard Dawkins made a claim that we lost hair because of wearing clothes. So do you agree with it?
No. So yeah, so I have a
so
couple things to say.
If you don't agree with it, then would you require at least Richard Dawkins, who made the claim, to change his position on evolution?
No, I'd require him to change his position on why we don't have hair. So I do have a response to this. I would grant that we do not know why humans are hairless. I would say that is unknown. That there isn't like a coherent scientific theory of why humans are hairless. And then the next thing I would say is, when people make predictions about something super specific, like, well, why is this particular phenotype apparent? The theory that they're staking that prediction on is not evolution. So he's not so when Richard Dawkins makes that claim, he's not staking evolution on there because it's clearly not a falsifiable prediction, right? So if it does turn out that Richard Dawkins is wrong, there's no logical reason why evolution must necessarily be wrong. However, the Darwinist claims in the 19th century about the teeth of Archaeopteryx, it is logically necessary that evolution is false if Archaeopteryx does not have teeth. And so that's why that's powerful evidence. In the Richard Dawkins case, he's not making a falsifiable prediction. He's not making a scientific claim. And so he's not staking evolution on his claim.
Okay, I do understand that. I do understand that. But my argument would be like, so when something as simple as hair, why we lack hair, could not be explained, even though we are one species, like human beings are just one species, and something as simple as that can't be explained, then there is really narrower. I mean, the scope is getting narrower to explain the bigger things. And in case of Darwin, who predicted a creature to have teeth, an intermediary species to have teeth, I think it worked out in his favor. I think it's one of those combinations and permutations and combinations. The scope is just plenty. It's like a lottery ticket. You know what I mean?
I have a question.
It doesn't really explain the gravity of the assumptions made of evolution itself. What it just tells is, okay, he made a prediction, and we see that his prediction was a lottery ticket, but that doesn't really explain the scientific.
I would say he, over the past 150 years, have made thousands of predictions like this, thousands. But I do have, I think, a good question, which is, can you think of any view other than evolution which would necessarily be wrong if Archaeopteryx didn't have teeth? Would it falsify any other view in the world other than evolution? Or is evolution the only one that could be wrong if that turned out to be false?
I don't necessarily see because none of the premises of evolution definitively point at predicting such an outcome for an intermediary species to have teeth, in case of like Archaeopteryx, for example.
I'll explain why.
I don't see what evolutionary I should say like what sort of study in those set of species from that family of from the dinosaur family, what became the precursors for what elements of knowledge from the genomes of those species that Darwin was observing became the leads for him to predict such an outcome for an intermediary species to have had teeth. I would be looking at the premises of where this prediction originated, where this prediction stemmed, the quality of that background work that made Darwin make such a prediction. I would want to examine that side of the story, that side of the paper, where he describes, therefore I predict. So I would be keen to look at that, investigate that. You know what I mean?
And after the debate, I can actually link you that story. But part of it is, it's absolutely true that our evolution is hinged on this, and there are good reasons for this. So,
but even if I was, for example, let me clarify this. Even if that were not to be true, I think evolution is not premised on such a prediction. The theory of evolution is so generic. It is not specific at that level that if a species with no teeth wasn't found, it would collapse the theory of evolution. It's not really hinged like that.
So it's not a lack of finding something, because if you fail to find something, you could always say, well, I just didn't find it. It's not that it doesn't exist. It's just that I didn't find it. So it's not a lack of finding something. It's finding something that does exist and it doesn't have what you need it to have. And so the reason you needed to have this is because after the discovery of Archaeopteryx, they discovered actual birds with beaks that had teeth in them. And these birds were in higher layers than Archaeopteryx. So under the evolutionary view, they necessarily must be younger than Archaeopteryx. And again, from your view, you can disagree on that, but from the evolutionary view, it has to be younger than Archaeopteryx, which means it came after Archaeopteryx. But and then another thing is, on the concept of monophyly, it is necessarily true that birds come from reptiles. If you find if you find that birds are not monophyletically embedded within reptiles, then that would also falsify the theory. And so, because of these two facts, the facts that the transition needs to be between reptile and bird, and that tooth birds are posterior or chronologically after Archaeopteryx, well, then the ancestor of tooth birds can't be toothless. It's impossible.
How does monophyly treat platypus as an animal? How does
Mammal.
monophyly treat that as an animal?
Mammal.
Mammal?
Yep.
Mammal, but it has beak, right?
Doesn't have a bird beak. I forget what material the platypus beak is made of. I think it's made of the same material that it's made of, like the same material that
usually touted as duck-billed platypus.
I'm sorry?
It's touted as a duck-billed platypus.
Yeah, so it looks like a duckbill. It's not made of the same material as a duckbill. It's made of like the same material as nails. I think. I could be wrong on that, but it's definitely not made of the same material as a bird beak, for example.
So what do you insinuate from that? What do you infer from that?
Well,
if the material is different,
so what understand the question.
So if the material of the platypus's beak is different, what do you necessarily infer from that?
Oh, okay. So then the beak of the platypus and the beak of the bird have no monophyletic relationship.
Okay, just based on the material.
Based on the material and also based on the genetics.
And what is packed up when you say genetics? Based on genetics, what is packed up there? Can you unpack it?
Sure. So you would agree that genetics cause traits, right?
Yeah.
So the genetics that cause the mouth of the platypus should be unrelated to the genetics that cause the beak of a bird. And so this is another prediction I can make live, that if you look into the genetics, and I haven't looked at them, but if you do, they're going to be different. They're going to be fundamentally different, in fact. And if this is actually a falsifiable prediction too. If I'm wrong on this, I will admit live that evolution is false.
No. I don't want you to rush into making these predictions. And
I am boldly making it.
That's fine.
The genetics will not be the same, and the material will also not be the same.
Okay, cool. I mean, I grant that to you. You can make those predictions, but I would say, why would you argue as fundamentally different when the beaks are fundamentally tools with which the species forages? So the beaks are meant or fundamentally there to forage, to eat, and to survive. So why would you go on to then say the beak of the where do you draw the line in genetics of the beak? Where do you draw the line? Why would you say they're fundamentally different when we know that the beaks are meant for foraging?
Genetics are going to cause the material. Genetics are going to cause what kind of teeth it has. Genetics are going to cause the shape of it. Genetics are going to cause the embryological development of it. This is another prediction I would make, is that the way that beaks appear in the embryo of birds is quite different than the way that beaks appear in the embryo of platypus. Man, I was going to say something else. I had a question, which was, let's say I build, I build a tool and it uses a beak for very similar things that birds use beaks for. Would you say that my tool is fundamentally the same thing as a bird beak?
No, but species do use their beaks to forage. That's the fact that you can't really. The analogy that you're trying to bring now is not a.
I would say the utility of a thing has nothing to do with what it fundamentally is metaphysically.
Well, Darwin basically argued based on the utility premise. When he observed the finches pecking, he ordered them based on their pecking methods. And pecking floor would have blunt and shorter beaks, and pecking on the flowers had different So basically, Darwin came up with this premise. I'm not even articulating something of my own. Darwin says the behavior of pecking does entail in speciation. That's his proposal. If you're not aware of
That's pecking. Sure, yes, yeah. Genes
changes,
can,
yeah.
yeah. So genes can control for behaviors as well, and I would also bet that the behavior of the platypus has different genetics and
So something
behavior.
as fundamental as that, that would usher in a feature such as a beak to a forage. Why would you say it would be fundamentally different? I mean, that's a bold claim.
So yes, so based on the
y-
theory of evolution, I would predict that even the behavior is genetically distinct and has different genetic causes in between platypuses and birds.
So yeah, I mean, I would be keen. I mean, if you don't want to, like, I would encourage you to actually do some research on the fruit fly subspecies
If you
and
could send
try
me
to
a
get
link
at
on
the
that, yeah,
scientific evidence.
I'll look into that.
Try to get the scientific evidence there from genetics, and also I would encourage you to lay out a detailed description of the beak of the platypus as to why fundamentally it is different. And I would be interested to see what sort
Okay.
of evidence that you would bring to the table there,
I mean,
and
do you find my bold
see.
claims completely uncompelling in your view?
No, I mean, I have. If you read my books, I've also made claims that I just told you, and I don't necessarily treat claims on the equal metric as that of scientific evidence. Claims are claims, and we can't hold people for claims and destroy something as a theory that has a popularity at a community level popularity. I can't hold the theory of evolution to be. Uh, I can't undermine because just because Richard Dawkins made a blunt claim or a blunt prediction. So I don't necessarily treat claims and assertions that have graduated as a community level organized um, tools for seeking out evidence based on individuals' personal assertions or claims, if that makes sense to you.
Okay.
I'm more keen on looking at graduate level evidence
Would it
that's
make
out
sense?
there.
Hmm. Okay. Would it make sense to you if I were to say that what I'm referring to when I say there's a fundamental difference is I'm relying on the concept of monophyly, and I'm saying if you take all of the diagnostic traits which would define a platypus and compare them to the diagnostic traits that define a bird, you're going to find that there's distinctions there, even in the beak.
Yeah, I mean, I would be interested to see what you have to present there, not just in relation to the beak, but platypus would be a very good example because we had a long time struggle to classify that animal into a particular tree of a species. So that is a very good example that we can work on to ascertain monophyly and its concept. So I would want to see how monophyly as a concept works best with platypus.
Okay. Yeah, and if you could write down all of your questions you have for me after the debate, I'd be happy to look them up, and we can do another conversation
Yeah,
on those specific topics. So I guess we can
yeah.
I guess it's about time to wrap it up. I do have some closing thoughts. Um, what I was going to ask you
Yeah,
is
yeah. Thank you for giving me the opportunity to to to
yeah, this was
close the
fun.
thoughts. I
Thank
mean,
you.
yeah, it was definitely fun talking to you, for sure. And I would like to see more come out of it because um, I have written a book, as I said to you 7 years ago, and I wrote that book as a response to Why Evolution is True by Jerry A. Cohen, the evolutionary biologist in the University of Chicago. I loved his book. I tried to read Richard Dawkins's books, but somehow I could not. I forced myself to finish them, but I could not. But this guy Jerry A. Cohen had it written so well that I could not. I could not stop it. I finished it, and I wrote a response. In effect, what I see is even in his book, he mostly brought in the observation, the evidence based on observation, and he also brought in some genetic evidence which he claimed was good enough, like vestiges, the vestigial genes. But I did not see those as compelling arguments because I have an explanation of why we would find vestiges in genomes of various different species. We humans still carry the vestiges of a yolk, and I have an explanation for why that is. So that side of the story was never compelling to me, but his book was a good read, and I wrote a response. And I would really want to see scientific evidence, as in a very simple claim, like, why did human beings lost their hair, or why, or this example, the fruit fly example. These two cosmopolitan species, Drosophila and Simulans, what where is the trajectory of the speciation? Like, and I would be super keen to see that explained in genetics.
Okay.
And then I would
And
then that would point directly at the environment. I would say, oh, because of these reasons, exact reasons, speciation occurred. So I want to be able to establish that relationship for natural selection to be a worthy idea with which to look the origins of species and the diversification and the biodiversity. So
okay.
as long as we don't, because these are two prominent things of this theory, and we should have credible evidence to credit these prominent claims of the theory, which is environment works, genetic changes, right? So we need to be able to see genetic trail or trajectory of changes, and then we will be able to associate them with the environmental factors that actually induce them and cause them, right? So
Okay. I believe there have been
yeah,
actual experiments on the subject of like what actually causes genetic variation, and so maybe that's a maybe I can read that, and that could be a topic I could bring up next time.
yeah, yeah.
Because
And
there are
my
actual like
response would be,
scientific papers which argue for the dysteleology of what I'm calling
gotcha.
generative sources of variation.
But you know my answer to that, right? My answer to that is genetic elasticity, right? So you know that answer that I have for it.
Sure.
So
Yeah, and I
yeah,
think like
gotcha.
regarding the Richard Dawkins example, that I think in communication of science there is a lot of confusion between what is the interpretation and what is the claimed evidence. So a lot of
Mm,
these claims about like Richard Dawkins' theory of why humans are hairless, that's his interpretation. That's not his evidence, right? And so he doesn't actually
mm,
have evidence
mm.
for why that's the case. And
Gotcha.
so this is kind of the distinction that I'm trying to make is that there is interpretation in science, but but it's not it's distinct from the evidence part. The interpretation,
Yeah,
the theory is the interpretive lens that you're using to make the predictions. And
gotcha.
just as a closer, I wanted to ask you, so if we do this again and I come back with a compelling like monophyletic distinction between say African and Asian elephants, would you consider that to be scientific? And I'm going to clarify the question before you respond, because just because there is scientific evidence, that doesn't mean that a claim is true. It just means that there's evidence for it, and that's the
Yeah.
topic of the debate. So we're not arguing whether evolution is true. We're just arguing whether there is within epistemology of science, if there is some justification within that for believing it. And so my question to you is, if I could find monophyly between the different elephants or between these fruit flies, would you consider that some form of scientific evidence?
I should admit the fact that I'd never looked into monophyly and clade at the level that you are familiar with. So I would be first of all making my preparations to get my to wrap my heads around the concept of monophyly and clade. So I would appreciate if you can send me some information on my email that I can actually read and become aware of those two things. And then obviously I will have a base from where I can develop my own reasoning and see the accounts of how you are trying to project your argument to the elephant's case and also to the platypus and see how it all holds up. So
That could be a fun topic as well.
yes, certainly, I'm looking forward to that. And yeah,
Well, before I go, did your audience have any questions that I can answer? Or
yeah. Let me have a look. I was not looking at the audience at all, and there's very few audience at my end. How about you? How many
yeah,
audience do you have at your end?
I have nothing. So none
Okay,
from my end.
so to my audience who are watching us, do you have any questions?
Yeah, we can give them a couple minutes if there's anyone watching, and then probably wrap it up from there.
Brenda, I see Brenda Debates has something here on my channel. Do you have any question for me or for Evo? Let us know. Let us know if you have any questions for me or Evo. Otherwise, we are going to wrap it up in like a couple of minutes, I suppose. Evo, it was fun to chatting to you and talking to you and discussing the subject with you today.
Likewise.
And I bet my atheist friend here would be super interested to watch this debate, and I'll pass on this link
Cool.
to him. Yeah. And yeah, I mean, if you want to go ahead and say something about how you felt, go ahead.
Yeah, I mean, I enjoyed the debate. I do agree with you a little bit that we strayed from the topic a little bit. The topic is because we got a lot into interpretations and different ways we would expect certain outcomes from interpretations, and we also got a little bit into philosophy where we're talking about like teleology and purpose, and that's not necessarily what the debate is about. I think those are all interesting topics in their own right, but overall, obviously, I would stand by my opening statement, and I guess I can reiterate my 3 points. My 3 points from my opener were 1, descent with modification by natural selection is the mechanism for speciation. 2, evolution is the only model which provides an interpretation of species flux, the fossil record, and extinction that makes testable predictions. And 3, that because of this, these premises qualify evolution as a scientific theory that has scientific evidence. And that would be my closing statement.
Yeah. Okay. So on the flip side, the first claim that you made would require genetic evidence, as in a trajectory or a trail of changes captured in the genomes of species to demonstrate speciation really occurs. And the second claim that you brought to the table would be like there is this concept of genetic elasticity in design that goes on to acquire traits, and once they acquire traits, they become permanent traits, and also that evolution, also that speciation is possible from the placental ancestors. That's one of the premises I think I did not bring to the table, but which is a doctrine in the Quran, especially with animals that are usable by human beings, like domesticated animals. God clearly says in the Quran that He brought about them from by a selection of descent through placental outcomes. I think Ibn Khaldun, back in the day, in medieval times, based on these passages of the Quran, he sort of promoted that all species came from one origin, one single origin, which is not a surprise to me that back then he made that claim. But today we have advanced tools into investigations, and we don't see that necessarily to be true. All right, so it's possible that people understood some passages of the Quran and misunderstood others. It's possible even today people make those mistakes because we are people. And Ibn Khaldun necessarily did some hypothesis, which later on Richard Dawkins caught up with it and went on and advanced the model of evolution by natural selection. But I'm of the premise that we do need to find evidence based in the genomes of the species to be able to assert that we have scientific evidence. So that would be my closure. So it was fun talking to you, Evo, and looking forward to more discussions in the future and debates. And yeah,
Absolutely.
I would like to keep it. Yeah. So looking forward to that. So that's all for today, guys. And appreciate your likes and your subs and sharing of this content and joining us future to ask us questions at the end of the debate. So thank you, everybody, and have a good day.
All right. Thank you.